Yes. It does not have a radical. It has a ratio. That's why it's rational. A rational function is a ratio of two polynomials. A radical function will be something like this, and we're going to look at it. Let's say 2x minus 1. That's a radical because it has a radical in it. Good. Ready for the difference quotient? Yes?
Yes.
Thank you. Okay, so for the rational function, I don't have to go through all those steps, meaning I don't have to separately determine f of x plus h. This is specific for the quadratic or cubic or polynomial functions because this is much longer and I don't want to write the whole difference quotient 10 times. But for the rational, I can go ahead and write the difference quotient. I will write the definition, which is f of x plus h minus f of x divided by h. And then I can immediately fill it in. So this is 1 minus 4x minus 4h over 2x plus 2h plus 1 minus 1 minus 4x over 2x plus 1. I can write it here if it's not clear. So f of x plus h is 1 minus 4 quantity x plus h over 2 quantity x plus h plus 1. So I need to distribute -4 to these two terms and +2 to these two terms. And of course divided by h. Is everyone okay with this so far? Any questions? I don't want to touch anything. Okay. How do we handle this? What do we need to find first?
The terms that would cancel each other, like -4x and +4x.
Careful. Remember what I said? Please tell me anything you can think of so I can correct it.
Would you find a common denominator?
Very good. We have to find the least common denominator. So I cannot simplify this with this by any means because the denominator is not the same. So I have to find the least common denominator. Can anyone give us the least common denominator?
Would you multiply
Is
the
it 2x plus 2h plus 1 minus 2x plus 1?
So the least common denominator has to be the product of these two quantities because they have nothing in common. So let's talk about this for a moment. So if I have 1/2 minus 1/3, 2 and 3 have nothing in common. They're prime numbers. They do not have a common factor. So it must be the product of the two, which is 6. Then 2 was multiplied by 3 to get 6. This is my note. It's not a fraction line. It just says you took the liberty to multiply 2 by 3 to get 6. You have to do the same thing to the top. Because if you multiply the denominator without multiplying the numerator by the same quantity, you change the value of the fraction. And you cannot do that. So 3 was multiplied by 2. I took the liberty to multiply 3 by 2 to get 6. Well, I am forced now to multiply the top by the same quantity. 3 times 1 minus 1 times 2, which means 3 minus 2, which means 1/6. This is exactly what we're going to do here. 2 and 3 have nothing in common, so that's why it's the product of the two. Same back here. This and this have nothing in common. The least common denominator must be the product of these two. And exactly how I showed a second ago, this top, or maybe I should say it differently. This denominator was multiplied by 2x plus 1. My note to myself is this. You multiply the denominator by 2x plus 1. Make sure that you multiply the numerator by the same quantity. You multiply 2x plus 1 by this factor to get this. Then you have to do the same thing to the top. It's a mandatory situation. 2x plus 2h plus 1. So I have to create this product. This is a polynomial of 3 terms, a trinomial. This is a polynomial of 2 terms. How do I multiply 2 terms by 3 terms? I distribute 2x to these 3 terms, then 1 to these 3 terms, then 1 to these 3 terms with minus in front, then negative 4x to these 3 terms and with minus in front. Of course, you're going to watch me run out of room. Sorry, it will always happen. That's my MO. 2x times 1. 2x times negative 4x. 2x times negative 4h. 1 times 1. 1 times negative 4x. 1 times negative 4h. All this is this product.
Did you already cancel 2x, or you just didn't multiply 2x times 1?
So these 6 terms are 2x times 1.
Okay.
2x times negative 4x. 2x times negative 4h. 1 times 1. 1 times negative 4x and 1 times negative 4. I did not simplify anything. I did not get that far yet. One times 2x with minus in front. 1 times 2h with minus in front. 1 times 1 with minus in front. Negative 1 times negative 4x. Positive 4x times 2x. Positive 8x squared. Of course, I have to run above, right above. This is 4x times 2xh plus 8xh and 4x times 1. So these terms follow here. Please do not write them above if you don't need to. I had no choice. As I mentioned from the get-go, I will always run out of room. Maybe I should write on a landscape instead of these difference quotients. Okay, what did we say has to happen? 1, 2, 3. What did we say?
All terms without h has to simplify.
If they don't, I'm in trouble. 2x, yes. Negative 8x squared, yes. Negative 8xh, nice. This didn't have to simplify, but it does. Awesome. Positive 1 with negative 1. Negative 4x with positive 4x. And let's see what is left. And nothing else. So what is the top? Can anyone give us the top?
Negative 1 minus 2h minus 4h. Or minus 6h.
If I have a negative 1, I'm in big trouble. If I have a negative 1 left at the top, I'm in big trouble.
It's negative 4h minus 2h.
Negative 4h minus 2h. How much is negative 4 apples minus 2 apples?
Negative 6h.
Negative 6 apples. Awesome. Divided by 2x plus 1, 2x plus 2h plus 1. And how do we divide two fractions? I copy the fraction from the top, and I flip h over 1 into 1 over h.
Like keep, change, flip.
Say that again.
Keep, change, flip. Like keep
Excellent.
the top, change it to multiplication, and then flip it.
Excellent. So number 1 is done. Now I'm expecting number 2. Does it happen? If it doesn't, I'm in big trouble. Here it is. Awesome. And of course, I expect an age to be left in the final answer. And here it is. And this is, oh, and this is the final answer. Don't write that, of course, I'm gonna take care of it. As expected, all terms without age went away. Age from the denominator, this one, went away nicely, as expected. And the final answer still has age in it. All three were complied. This is gone, age is still there. Any questions? Okay, one
So
more.
H can remain in the denominator?
Anywhere.
Does it have?
This is
Okay.
not the one we were talking about. This age is not this one. This one from the denominator is gone in step 2. The age in the final answer can be anywhere, but not this one. Very good question. Good, so you prefer this radical or you want to make one up, or is this okay?
That one's good.
Okay, so we have now f of x equals the square root of 2x minus 1. Before we continue, any questions on the previous problem? Please review adding and subtracting fractions and redo this problem several times till you don't have to look at it. It's a crucial problem, please. Okay, moving on. The difference quotient. I can write it already, but I will write the definition always first. The square root of 2x plus 2h minus 1 minus the square root of 2x minus 1 divided by h. Because this function is f of whatever equals the square root of 2 times whatever minus 1. If the whatever is x plus h, then I distribute 2 to x plus h. Are you with me, please? Anyone? Any questions? Is it okay if I leave this here and oh yes, of course. I did see it because I touched it. I touched the cord. Can I leave this here, or do you want me to start a new page?
You can start a new one.
Very good. Here it is. Good. So how do we think about this kind of function? What is the idea? What can we do here? There is a technique for radical functions that you saw in algebra and pre-calculus.
I don't know the reason behind it, but I think I know what to do.
Yes.
So you would take the top part, so it would be square root 2x plus 2h minus 1 plus
Excellent.
square root 2x minus 1.
Very good.
Put that over itself and multiply it on the other side.
Rationalize the numerator. Excellent. Who was that?
Christine.
Thank you. Rationalize the numerator. So if I have a minus b, I really want to multiply the top and the bottom by a plus b. So these are conjugates of each other. A minus b and a plus b are conjugates. Same terms, but plus and minus. So now the result for the top, that's why we started last week with this. That's why I wanted to put these three behind us. And this is what I'm talking about right now, the difference square of squares. Okay. Okay, so what do we get when we multiply a minus b times a plus b?
A squared plus B squared.
Careful, it's the difference of squares, okay? A squared minus b squared, and the denominator stays the same. A plus b. Now you understand that this is 1. Multiplication by 1 of anything will not change its value. This is the same with this, because I multiplied by 1. A plus b over a plus b is 1. So these two, when I multiply them, I get that, and then a plus b is the same a plus b. Why do I need to do this? Because this is the only way to eliminate the square root. Now, if I had the cube root here, the procedure would have been different, because I need to use a different formula. But because the index is 2, we do not write it. By convention, we do not write the index 2. Because the index is 2, then I use the conjugates to get a squared minus b squared when I multiply these two. Again, if this index is 3, this procedure doesn't work because I have to use the difference of cubes and the sum of cubes, not the difference of squares. So let's continue. So I'm going to put multiplication here and then continue on the next page. So we multiply by, exactly as Caitlin said, by the conjugate. Because we have here minus, because I have the minus, I need the plus. So this will be the square root of 2x plus 2h minus 1 minus the square root of 2x plus the square root of 2x minus 1, and the denominator is the same. 2x plus 2h minus 1 plus the square root of 2x minus 1. They have to be the same because this fraction has to equal 1. Otherwise, I change the value of the function. But now, when I multiply this by this, I have to use the difference of squares formula. I will copy the denominator because that does not change. Multiplied by age, of course. And now please tell me what we get in the numerator. Anyone?
2x plus 2h minus 1 minus 2x plus 1.
Very good. Let's write it like this for everyone to see, and then we'll distribute. Awesome. Who was that? Thank you. Thank you. I will remember your voices, but not yet. It will take me a while. Okay, perfect. So now back to our rules. We have 3 rules for any difference quotient. All terms without h must go away. H from the denominator has to go away, and the answer must have an h left in it. Otherwise, something is wrong, and I have to start from scratch. So I will distribute first. 2x plus 2h minus 1 minus 2x plus 1. H, the square root, 2x plus 2h minus 1 plus the square root of 2x minus 1. Yes, yes, exactly what I was expecting. Number 1 is completed. And now number 2, the numerator is 2h over h, the square root minus this plus the square root. So 2x plus 2h minus 1. I'm just copying from here. I know it's difficult for you to see, but of course I ran out of room. And step number 2 is accomplished. And step number 3 is also accomplished. Still has an h in there.